P2.1 Listing Outcomes, Sample Spaces and Frequency Trees. In this chapter, we are looking at calculating the probabilities of combined events. When two or more events occur, we can find all of the possible outcomes and therefore calculate the probabilities of each outcome occurring. We can do this in several ways. By listing outcomes, by using sample space diagrams, by using frequency trees, or tree diagrams, or Venn diagrams. In today's lesson, we will look at the first three. Then, over the next few lessons, we will look at the rest. So, let's first take a look at listing outcomes. Listing outcomes is where we systematically list all of the possible outcomes. We look for patterns to help us with this. One advantage of using this method is that it can be used when two or even more events occur. However, there are a few disadvantages to this method. First of all, you have to be very careful about the wording in the question. Also, it's not the most efficient method, and it is easy to accidentally miss out some combinations. Let's have a look at the first question. Number 1. A box contains a pink counter, a yellow counter, a green counter, and a blue counter. George picks a counter at random, notes down its colour, puts it back into the box, then picks a second counter at random. List all of the possible outcomes. What is the probability that he picks at least one yellow counter? So let's start by trying to visualise what is going on. George has got a box with a pink, a yellow, a green and a blue counter in it. He picks one counter out of the box. This is the first event. He looks at it, notes down its colour and puts it back into the box. Now, if this was the only event that occurred, we could work out the probability of each outcome, as there are a total of 4 counters and each different colour counter appears once. Then the probability of picking each colour would be 1/4. However, George goes on to complete a second event, taking another counter out of the box. We need to list all of the possible outcomes of these 2 events. Before we go ahead and list the outcomes, let's abbreviate the words that we will have to list. In this case, the colours of the counters. This will just save us some time not having to write the words in full. So a pink counter I'm going to abbreviate as P, yellow counter Y, green G and blue B. So we're going to use those codes for each of those individual outcomes. Now let's start listing all of the possible outcomes of the 2 events. Imagine if George started picking and he first of all selected a pink counter out of the box. He looked at it, noted down its colour and then put it back in the box. Now imagine George picking a second counter out of the box. Because he replaced the pink counter into the box, it is possible that he could pick the pink counter again. So picking a pink counter first and a pink counter second. Now let's continue to consider the scenario where George picks a pink counter first. He could now pick a yellow counter second. or he could pick a pink counter first and a green counter second, or he could pick a pink counter first and a blue counter second. So here we have got 4 different outcomes where George is selecting a pink counter first. Notice how I've systematically worked my way through the colours as they are written in the question. Now we need to consider if George picks a different colour counter first. Let's imagine him picking a yellow counter first. So he could pick a yellow counter, then a pink counter, or a yellow counter and a yellow counter, a yellow counter and a green counter, or a yellow counter and a blue counter. Again, I'm working my way through the colours as they're written in the question. And I'm going to continue in this way, imagining George picking a green counter first, then a pink, green, then yellow, green, then green, green, and then blue. And then my final row is if George picks a blue counter first, blue and then pink, blue and then yellow, blue and then green, and blue and then blue. So those are all of the outcomes of the 2 events. Let's take a moment to look how the outcomes that I've listed here are systematically organised. Each row starts with the same colour, so the first row starts with pink, second row starts with yellow, and so on. And each column ends with the same colour, so the first column ends in P, pink, second column ends in Y, yellow, and so on. A systematic approach like this means that you are less likely to miss out combinations. So now that we've found all of the outcomes, there are 16 in total, we can now work out the probability of picking at least one yellow counter. So we do this by counting how many of the outcomes have at least one yellow counter in them. So along the first row, we have got pink and yellow, there's one outcome with at least one yellow. Along the second row, we've got yellow and pink, yellow and yellow, that's included because at least one yellow means one yellow or more. Yellow and green, yellow and blue. Along the next row, green and yellow, and along the final row, blue and yellow. So there are 7 outcomes where at least one yellow was chosen. So the probability of picking at least one yellow is 7 out of 16. 7 outcomes that contain at least one yellow out of 16 outcomes altogether. And as this is a probability, we can leave that as a fraction. Let's have a look now at part B. This time, George picks a counter at random, does not put it back into the bag, then picks another counter at random. List all of the possible outcomes. What is the probability that he picks at least one yellow counter? So we've got the same question here, but a slightly different scenario. This time George picks a counter at random and notes down its colour, but then does not put the counter back into the box before picking a second counter. This means that he cannot choose the same counter twice. In other words, if he chooses a pink counter first, he cannot choose a pink counter second as well. So I'm going to systematically list all the outcomes for this scenario, And I'm going to use the answers to part A to help me with this. We're going to start with if George was to pick a pink counter first. He cannot pick a pink counter second. However, he could pick a yellow counter second. He could pick a pink counter first and a green counter second, or he could pick a pink counter first and a blue counter second. Now, if he were to choose a yellow counter first, he could pick a yellow counter first, then a pink counter second. He couldn't pick a yellow counter first and a yellow counter second, but he could pick a yellow and then a green, or a yellow and then a blue. Picking a green counter first, he could do green then pink, green and yellow, and he couldn't pick green and green, but he could pick green and blue. And then for the final row, blue and pink, blue and yellow, blue and green, but not blue and blue. So basically all of the outcomes from part A except for the diagonal, where two of the same counters are picked. So this time there are 12 possible outcomes, so we can calculate the probability that he picks at least one yellow counter. So counting how many of the 12 outcomes had at least one yellow counter in them, so 1, 2, 3, 4, 5, 6 outcomes out of a possible 12. So the probability of picking at least one yellow counter in this situation is a half. Let's move on to part C. This final time, George picks two counters at random from the box at the same time. List all of the possible outcomes. What is the probability that he picks at least one yellow counter? So again, we have the same question, but the situation has changed ever so slightly again. This time George picks two counters from the box at the same time. So this means that we no longer need to consider the order in which he selects the two counters. So if we're looking at part B, the outcomes for part B, selecting a pink counter, then a yellow counter, and selecting a yellow counter, then a pink counter, well, these were two different outcomes in part B. In part C, however, they are the same outcome, as picking a pink and yellow counter at the same time is exactly the same as picking a yellow counter and a pink counter at the same time. So when we write down the outcomes this time, we need to avoid writing down any repeats. I'm going to use my outcomes from part B to help me with this. So George could pick a pink and a yellow counter at the same time. He could pick a pink and a green counter at the same time. Or he could pick a pink and a blue counter at the same time. Moving to the next row, yellow and pink. Well, this is the same as pink and yellow, so this is a repeat, so we don't want that outcome. However, yellow and green at the same time, that's an outcome we've not yet had, and yellow and blue at the same time. Moving to the next row, green and pink, well, we've already had that, pink and green, so that's a repeat, so we don't want to write down that outcome. Green and yellow, well, that's the same as yellow and green, we've also got that outcome already. Green and blue we haven't though, so let's write that one down. And then moving on to the final row, in fact we've got all of these outcomes already. Blue and pink is the same as pink and blue. Blue and yellow is the same as yellow and blue, and blue and green is the same as green and blue. So basically we've got half of the outcomes that we had in part B because of these repeats. And now we can work out the probability that he picks at least one yellow counter. Well, there's 1, 2, 3 outcomes that have got at least one yellow counter out of a total of 6 possible outcomes. So the probability that George picks at least one yellow counter in this situation is a half. So it's your turn now to have a go at some questions like these. Be very careful of the wording in the question. Try to imagine the situation, think logically, and write down the outcomes in a systematic way to avoid missing any combinations. Pause the video to copy the notes, to check your understanding, and to try the questions from I'm giving it a try. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Let's now take a look at sample space diagrams. A sample space diagram is a diagram where we can record the possible outcomes of 2 events in a table. It is an organised and efficient method where you are less likely to miss outcomes. However, sample space diagrams are limited to 2 events only. Let's take a look at the question. Question 2. 2 fair 6-sided dice are rolled. The numbers on the dice are multiplied together to give a score. Part A. Complete the table to show all of the possible scores. Well, let's imagine first if we are using the listing outcomes method. 1 dice is rolled, event 1, and a second dice is rolled, event 2, and the numbers rolled are multiplied together to get a score. So we could get a 1 on the first dice and a 1 on the second dice, giving a score of 1. We could get a score of 1 on the first dice and 2 on the second dice, giving a score of 2. We could get a 1 on the first dice, a 3 on the second dice, giving a score of 3, and so on. If we were to use the listing outcomes method for this question, it is going to take a very long time to list all of those outcomes and calculate the scores. We need a much more efficient method to do this, and this is where a sample space diagram comes in handy. Along the top of the table is all of the outcomes of the first event. So dice 1, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. Down the side are all of the possible outcomes of the second event. So rolling dice 2, getting a 1 or a 2, a 3, 4, a 5, or a 6. Then inside the table, we can write down all of the outcomes of the 2 events. This one here is from rolling a 1 on dice 1 and a 1 on dice 2, multiplying those numbers together and getting an overall score of 1. This 2 here is from getting a 2 on dice 1 and a 1 on dice 2, multiplying those scores together and getting an overall score of 2. This 3 is from getting a 3 on dice 1 and a 1 on dice 2. This 2 here is from getting a 1 on dice 1 and a 2 on dice 2. again multiplying those together. So let's complete this table. So in this box here, we've scored a 4 on dice 1, a 1 on dice 2. Let's multiply those together. That gives an overall score of 4. In here, a 5 on dice 1, a 1 on dice 2, giving a score of 5. And so on. 6. Going on to the next row, we've got a 2 on dice 1, a 2 on dice 2, so a score of 4. Then a score of 6, then 8, 10, 12, and so on. 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20, 24, 5, 10, 15, 20, 25, 30, and then the final row, 6, 12, 18, 24, 30, and 36. So that method was much quicker, much more efficient, and I know that I haven't missed any outcomes. So in the table we can see that there are 36 possible outcomes of the two events. Let's use this then to answer the questions on probability. Part B. What is the probability of scoring part 1, 9? So we look in the table and count how many times an outcome of 9 occurred. Well, there is just 1 9 here, and that is out of a possible 36 outcomes in total. So the probability of scoring a 9 is 1 out of 36. Part 2. What is the probability of scoring 12? So let's count how many times we had an outcome of 12. So I'm doing this a row at a time. So there's a 12 here, the 12 here, and here, and also here. So there are 4 outcomes of scoring a 12 out of 36 outcomes in total. Now we can simplify that fraction. So the probability of scoring a 12 is 1 out of 9. Part C. What is the probability of scoring a number greater than 20? So that does not include 20. It means all of the numbers bigger than 20. So let's count how many of those there are. So none in the first row, none in the second row or the third row. The fourth row we've got 1 outcome that's greater than 20, and then we've got 2 in that row, and then 3 in the bottom row. So there are a total of 6 outcomes where the score is greater than 20 out of 36. So the probability of scoring greater than 20 is 1 in 6. Next part, we want the probability of scoring a number 6 or less. So this time 6 is included. So we're looking for all of the numbers in the table that are 6 or less. So there's going to be quite a lot here. There's all of these on this first row. They're all 6 or less. And then we've got 3 on the next row, 2 on the next row, and then 1 on each of the remaining rows. So that's 14. So the probability of scoring A number that is 6 or less is 14 out of 36, which simplifies to 7 out of 18. Finally, let's have a look at part D. What is the probability of scoring an even number? So we need to count how many even numbers there are in the table. So the first row, there are 3 even numbers. Second row, all of those are even. Third row, 3 of those are even. Fourth row, all of those are even. The fifth row, 3 of those are even. And the final row, they are all even. So a total of 27 of the outcomes were even out of 36 outcomes altogether. So the probability when you roll 2 fair 6-sided dice and multiply the numbers on the dice, the probability of getting an even score is 3/4. So that is an example of a sample space diagram, an organised way of recording all of the outcomes of 2 events. And then you can use the table to calculate the probabilities, counting the numbers of the outcomes in the table that satisfy the situation you need out of all of the total number of possible outcomes in the table. So it's your turn to have a go at some questions like these then. Pause the video to copy the notes, to check your understanding and to try the questions from I'm Building My Confidence. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. So finally, let's take a look at frequency trees. Frequency trees are used to record information that is given as frequencies. We start with the total number of our items. This is then split into categories. These categories are then split into further categories. Although these can be easily confused with tree diagrams, the numbers written on the branches in frequency trees are the frequencies, not the probabilities. Let's take a look at the question. Question 3. In Year 7, there are 150 students. Of the 68 boys, 11 of them are left-handed. Part A, complete the frequency tree. So let's take a look at the frequency tree then. At the front, we will have the total frequency. In this case, the total number of students in Year 7. This total number of students is then split into 2 categories. In this case, girls and boys. In this section, we will have the total number of girls in Year 7. In this section, we will have the total number of boys in Year 7. Those 2 categories are then split again into whether the students are right-handed or left-handed. So this number here, 73, tells us the number of girls in Year 7 that are right-handed. In this section here, we will need to write in the number of left-handed girls. In this section here, the number of right-handed boys, and here the number of left-handed boys. So let's fill in the frequency tree with the information that's given to us in the question. In Year 7, there are 150 students. So the total frequency, 150, goes at the front of the frequency tree. Of the 68 boys, 11 of them are left-handed. So, of the 68 boys, so that means there are 68 boys. So we put 68 here. And before we use the information about 11 of them being left-handed, we can use this information, 68 boys, to calculate how many girls there were in Year 7, simply by doing the total frequency of students in Year 7, take away the number of boys. So 150 take away 68 means that there were 82 girls in Year 7. So what we have done there is we have just split the total number of students into two categories. We can check that the total of these numbers is equal to the total frequency, so we can check 82 add 68 does give us 150, which is it does, so I'm going to continue with the question. So of the 68 boys, 11 of them are left-handed. So in the section for left-handed boys, we want 11. That means that we can work out how many right-handed boys there were by doing the total number of boys, take away the number of left-handed boys. 68 take away 11 means that there were 57 right-handed boys in Year 7. Now we don't have any more information in the question, however we are told in the frequency tree that there were 73 right-handed girls, so we can use this to work out how many left-handed girls there were. So the total number of girls, take away how many were right-handed, means that there were 9 left-handed girls in Year 7. So again, we can check our answers. We can make sure that 73 and 9 add up to give 82, which they do. We can also check that 57 and 11 add up to 68, which they do. But also, we can check that all four numbers at the end here add up to give our total frequency. So 73, add 9, add 57, add 11 is a total of 150. So to summarise the frequency tree, there are 150 students in Year 7, 82 of them are girls, 68 of them are boys, 73 of the girls are right-handed, 9 of the girls are left-handed, there are 57 right-handed boys, and there are 11 left-handed boys. So all of this information in one diagram. Let's now have a look at working out some of the probabilities. Part B. A student is chosen at random. What is the probability that they are a right-handed boy? So for this we need to know how many right-handed boys there are, which is 57, out of a total number of how many students, 150. So if you were to choose a student at random from the 150 Year 7 students, the probability that they would be a right-handed boy is 57 out of 150. The next part, what is the probability that when I choose a student at random, they are a girl? So I need to know how many girls there are in total, which is 82, out of how many students altogether, 150. So if I chose a student at random, the probability of picking a girl is 82 over 150, which simplifies to 41 out of 75. The third part, what is the probability that they are left-handed? So for this question we need to know how many students are left-handed altogether. Now we've got to be a little bit careful about this because we've got 9 left-handed girls and 11 left-handed boys. So we want the total of left-handed students. So 9 plus 11 out of 150 in total. So there are 20 left-handed students out of those 150 students. So the probability of picking a left-handed student is 2 out of 15. Finally, let's have a look at part C. A girl is chosen at random. What is the probability that they are left-handed? Now be careful with this question, it's slightly different. We are picking a girl at random, so we know that we are selecting a girl and we want to know the probability that that girl is left-handed. So we are only actually using this part of the diagram. So we know that there are 9 left-handed girls out of a total of 82 girls altogether. So given the fact that I know I am selecting a girl, the probability that they are left-handed is 9 out of 82. So it's your turn now to have a go at some questions on frequency trees. Make sure that you understand the frequency tree before you attempt any of the question. Make sure that you understand how the frequencies are split into different categories. Pause the video to copy the notes, to check your understanding and to try the questions from I'm Ready for Anything. Remember to mark your work and reflect on your confidence.